Hello students, welcome to Soft's classes. Today we will be solving the CSIR UGC NET questions from the June 2018 paper. We will be solving the set C of the mathematical sciences paper. Let's start off with question number 79. In question number 79 it has been said that let G be equal to S3, which is the permutation group of three symbols. In that case, option 1, G is isomorphic to a subgroup of a cyclic group. Option 2, there exists a cyclic group H such that G maps homomorphically onto H. Option 3, G is a product of cyclic groups. Option 4, there exists a non-trivial group homomorphism from G to the additive group Q plus of rational numbers. So this is what we have been given. Now we know that every subgroup of a cyclic group is cyclic. And if every subgroup of a cyclic group is cyclic, that means that it is abelian also. Hence, abelian. So this is the statement that we'll try to implement while solving this problem. Now it is known that Sn is non-abelian when n is greater than equal to 3. So if Sn is non-abelian, then G, which is equal to S3, is not any cyclic group. And if it is not any cyclic group, that implies that G is not isomorphic to a subgroup of a cyclic group. So that implies that option 1 is false. Now let us shift our focus to option B. So now in option B, option 2, there has been said that there exists a cyclic group H such that G maps homomorphically onto H. So let us define a mapping phi which goes from S3 to Z2, where we'll define that phi of A is equal to 0 when A is even permutation, and phi of A is equal to 1 when A is odd permutation. So if this is the condition that we are trying to define phi, then that will imply that therefore phi is a homomorphism. So if phi is a homomorphism, that means that phi maps S3 homomorphically, maps S3 onto Z2 homomorphically. And if this is the case, then we can definitely write that this Z2 is nothing but equal to H, can be H. So therefore option 2 is correct. Now let us shift our focus to option 3. In option 3, it has been said that G is a product of cyclic groups. Let us assume that G is a product of cyclic groups. Okay, so now if G is a product of cyclic groups, that implies that the product is also abelian. Since we know that cyclic implies abelian, so the cyclic groups we can also write that they are product of an abelian groups. So therefore we can write that S3 is a product of abelian groups. But this is not true. This is a contradiction. This is not true. This is not true. So therefore our assumption that G is a product of cyclic groups is wrong, and therefore option 3 is also incorrect. Now let us shift our focus to option 4. Now in option 4, let me insert another page over here. Now in option 4 it has been said that if, let me take you back to the question. Okay, the question was that if G is equal to SC and the permutation group of 3 symbols, then option 4 is that there exists a non-trivial group homomorphism from G to the additive group Q, plus of rational numbers. So this is what we need to solve. So option 4 was there exists a non-trivial group homomorphism from G to the additive group Q plus of rational numbers. This is what we need to find out. So now we know that every element of S3 is of finite order. We don't know that for sure, that every element of SC is of finite order, but element of the group Q, plus, except the element 0 is of infinite order. So every element of SC is of finite order, but every element of Q and plus of the group Q plus except the element 0 is of infinite order. So therefore there exists no non-trivial group homomorphism on Q plus. So therefore option 4 is false. So therefore the correct options are option 2, only. So the correct option is option 2. So today we have solved question number 79 from the CSIR UGC net question paper. We'll be solving the next questions in the subsequent videos. Till then, keep watching Solve This Class videos for more solutions and content. Thank you very much.